Quantum mechanics can be both strange and baffling. Sometimes, studying quantum mechanics, you feel a bit like Alice in Wonderland, as if you've fallen down the rabbit hole. And one of the most amazing things about quantum mechanics is that of entanglement. My name is Dr. Krister Scham, and today I'm here at the Institute for Quantum Computing to try and answer the question, what is entanglement? Come on inside to one of the labs and let's see what we can find. When two objects are entangled with one another, they share a peculiar connection. For example, if I were to take these two molecules and entangle them with one another, I could then take them to opposite ends of the universe, and yet they'd still be connected. Anything I did to this molecule would instantaneously affect this one. Einstein so disliked this concept, he termed it spooky action at a distance.
Nein, ich mag diese spukhafte Fernwirkung nicht. Nein, nein, nein!
Entanglement was the subject of some of the most vigorous debates between Einstein and Niels Bohr, and has played a profound role in the foundations of quantum mechanics. But what's entanglement good for? Well, using entanglement, two people can share secret messages between them. Or you can use entanglement to build a super fast computer capable of solving problems that today's machines can't handle. In fact, you can even use entanglement to teleport the information stored in a quantum system from one place to another. Pretend for a moment that I'm an atom. Then using entanglement, I could teleport the quantum information stored within me from here to here or here. Quantum entanglement is so strange, it's almost magical. And here to help explain quantum entanglement is special quantum magician Dan Trompeter.
Thanks, Krister. Using this deck of quantum cards, Jamie and Krister will help me demonstrate the idea of quantum entanglement. First, I'll mix the cards, and then I'll have each of them mix the cards as well. But first, Jamie, please cut off about half of the cards, and then deal those into two piles. One pile for Krister, and one pile for yourself. This mixing process right now is just, in a sense, a type of shuffling, mixing into two different piles. Now that you each have your own piles, you'll mix them independently. You'll deal as many cards as you like face down. Whenever you like, you can stop. Then you take everything in your hands, turn it over, lay it back down. Pick it up, and then do that again as many times as you like. Go ahead. Deal face down, good. Fantastic. And you'll note that they're making independent decisions. Sometimes Jamie's just dealing a few, sometimes she's dealing more before she turns over. Same with Krister. Also note, Jamie stopped already. Krister continues to shuffle. Independent decisions. In fact, you could take these two different decks of cards, take them across the universe, and yet, because they're entangled, something very mysterious will happen. You would think that because of those independent choices and shuffling procedures, that they would have random orders. When in fact, if we look at the top card of Krister's pile, it's a black 6. The top card of Jamie's pile is also a black 6. Maybe a coincidence. Let's try it. Top card of Krister's is a red jack, red 10, red 10, 5s, 9s, 8s, 3s, 8s, 3s, aces, and queens. Because they're quantumly entangled, they have a mysterious correlation, and that is quantum entanglement.
Dan's quantum card trick illustrates one of the most amazing things about quantum entanglement: surprising correlations. You see, even though Jamie and I got our own separate sets of cards, and even though we independently shuffled them, they still remain correlated. Whenever Jamie got a black queen, I got a black queen. But in the lab, we can't use magic to create entanglement. Instead, we have to use some very advanced techniques and technologies. But in the lab, when we entangle two systems, they share correlations that are even stronger and more shocking than those in Dan's quantum card trick. One of the ways in the lab that we can create entanglement is to use very powerful lasers along with some very special crystals in order to entangle pairs of photons, which are the smallest units of light. We can also use atoms, ions, and superconductors to create and study the properties of entanglement. Entanglement is at the very heart of many of the new quantum devices and technologies that are actively being developed. In the future, entanglement may play a critical role in many of our consumer electronics and devices. If this ever happens, then who knows? Maybe entanglement won't seem so spooky.